Okay, I'm doing a quick review right now of the trigonometric identities that you learned in your pre-calc class. So did I. And you're going to be using these identities throughout the entire calculus class, so it's a good thing to know them from the beginning because they start up even in the limits chapter that this video is currently in. So if you remember from last year, through a proof, you learned that sine x plus sine squared x plus cosine squared x equals 1. And then remember, there's the three Pythagorean identities, but you don't need to memorize them, because if you think about it, divide all of this by sine x, and you would get sine x over sine squared x over sine squared x, which is be 1, plus cosine squared x over sine squared x, which is be cotangent squared x, plus 1 over sine x, which would be cosecant squared x. Then, if you divide this original one, divide everything by cosine squared x, you would get tangent squared x plus 1 equals secant squared x. This should all be review from pre-calc. Okay, then the second thing is the double angle identities, which you're going to be using a decent amount the second semester of calculus, but it's getting to know them. Just remember that sine of 2x is the same thing as 2 sine x cosine x. Remember, we did a big proof of this in pre-calc, but I don't think that we want to do that entire thing again, so hopefully you can just trust me. That's what that is. And then cosine of 2x. Remember, there's the three different ones for this one. There's 1 minus 2 sine squared x. Then there's 2 cosine squared x minus 1. And then last but not least, there's one that you rarely ever use, but it's cosine squared x minus sine squared x. There's also a tangent 2x, but you don't really use that in pre-calc, in calculus. If it comes up, it's 2 tangent of x over 1 minus tangent squared. Yeah, and these two you're going to be using a lot in the opposite direction, where instead of solving these and making equal cosine 2x, you want to solve them for sine squared and cosine squared. I'll probably get into that later, but basically just know that if you solve this for sine squared x, you would get sine squared x equals 1/2 minus 1/2 cosine of 2x, and cosine of 2x, I'm writing really weird, I'm sorry, is 1/2 plus 1/2 cosine 2x. This will come up way later, but I may as well just address it now. So, yeah.